SmartTrackMe. Let's have now a quick overview of the whole project. All the aspects that we are seeing here are more deeply analyzed in the following part of this video. When a customer wants to send a packet, comes to our office, where from the website we can create a new packet and add it to the database. After that, we can find the specific packet and get the statistics and its location on the map. Our operator on the field has to use the mobile application we developed in order to say that the packet is on the track and that the packet has been delivered. While the packet is on the way, our sensor on the track continues to send the raw data to the ThingSpeak server at a given rate. From the Telegram bot, we ask for a specific packet that is looked for in the database, and from ThingSpeak, we retrieve the real-time data of the sensors related to the packet. ThingSpeak also sends data to a Python file we created for further analysis. Eventually, the raw data and the elaborated data are all plotted in Freeboard to see the overall journey. If something goes wrong during the travel, we can set an alarm and display it using the Telegram bot.
Let's now have a look at how the insertion of a packet works. We developed this web page in which we have to fill this form with name, complete address, city, zip code and telephone. And then through this send, we are sending a get to the database that is putting the packet in the system. So we do send, and what are we retrieving is the packet identification code and a QR code that scan give us exactly this packet identification code. So if we now go to the database, we can see that this was the situation before the insertion, and if we refresh, now we have this new packet that has this packet identification code and the attributes that we put inside the form. Let's have a look at how our database works. Our database is composed of two tables, the packet tables and the packet and track tables. In the packet tables, we store all the information about the packets saved in our system. We have the packet identification code, the attributes like name, address, zip code, city, telephone number, and latitude and longitude. These two fields are actually computed through an API of Google based on the complete address of the user. In the packet and track table instead, we store the association between packet and track. For example, this packet is in this track and is not being delivered, while this packet is in track 2 and has been delivered. How is database able to interact with other applications? We have decided to create the database as a cherry pie server that then is able to save, update, or retrieve information through the get method. Let's see some examples. This one, for example, is the find association that is able to, given a packet ID, retrieve the track in which the packet is. Or we have the find packet that is able to retrieve the latitude and the longitude of the packet. Then we have the packet in track that tell us if a given packet is in a given track. And then the most important, we have the create that is able to create and run the query to insert a packet in the database. We can see that here we do the conversion of the address in latitude and longitude. Here we create the packet ID number, and then we insert the packet and create the QR code.
Let's start by taking a look at the configuration file, which is a JSON where we load the characteristics of our system. The first thing we have is trucks. Here we have one truck, and here we have another truck. Each one of them is associated to one channel on ThingSpeak. Inside the truck 1, we have parameters like channel name, sampling rate, which is the rate we are going to send data from Raspberry to ThingSpeak, and then we have here the 3 types of measurements we are going to collect. For all of them, we can enable or disable them, and for temperature and humidity, we can set thresholds. Here, as we said, we have the second channel. Then we have here topics. Inside this, we do the match between the measurement we are collecting and a field on the channel on ThingSpeak. Then we have the broker address that we use for the MQTT communication, and key and user that we use to access our channel on ThingSpeak. The next one we have here is Telegram. Here we show the functions we are offering in our Telegram bot, and we can again enable or disable them. The last 2 things we have here are database and analysis addresses. That are the addresses we need to communicate with those files. The next file we are going to take a look is the setup. Here we load the configuration file that we had. Then we delete all the channels that we had in our account on ThingSpeak and create new ones based on the parameters we set in the conf.json. For these new channels we have created, we are gonna get the channel ID and the channel key. And we are gonna write in the catalog that initially is an empty JSON all the information we have here in the configuration, and also the channel ID and the channel key for each one of the channels. Let's run the setup and see what happens. We can see here deleting all channels. We are sending the request to delete them. Then we come creating channels. We are sending the request to create the channels, writing the catalog, and setup completed. Now, if we come here, catalog, we take a look, we have the same information we had previously, but now we have channel ID and channel key that we are gonna need to access this channel and to write in it. The same for the second truck, and here the information we already had. The file I'm gonna show now is the home catalog, which is the web server we are using to expose the information that we had in the catalog.json to the other services we have in our system. So depending on the parameter we pass in the request, we are gonna send one information. So for example, topics, broker, Telegram key, and so on. So we come here down in our code, we have our cherry pie, and now we are gonna run this code and see what happens. So here we have our web server. We can copy this and make a request so we can test. For example, I'm gonna request topics, and we have here warming field 6, temperature field 1. That is the information that we had in the catalog.json. So let's make another request. For example, key. We have here the key of ThingSpeak. We can also check, for example, Telegram. We have the functions we are offering and also their status.
To manage the communication between the Raspberry and ThingSpeak, we just use the MQTT connection. So we define an MQTT host, mqtt.thingspeak.com, and while we are getting the data of temperature and humidity from the sensor, we are simulating the data of the GPS. We thought about 2 different scenarios. One, it's a short distance trip, for example for food delivery, and this is a GPS JSON going from Porta Nuova to Corso Duca degli Abruzzi. And this one that is a long distance trip that we imagine to go from Lecce in the south of Italy to Turin, so for about 1000 kilometers. So, for each field in the GPS file, what we do is we get the data from the sensor, we check if these data are in above or below some given thresholds, and then we publish, given a topic, the payload. We do this at different rates. This is because if we are in a short range delivery, we are interested in updating the value every 1 minute, for example. While if we are in a long distance, maybe we are not interested in having the position and the temperature every minute, but we are interested in every hour. This is a parameter that we can set directly from the catalog. Now we are going to see how the Raspberry is updating the ThingSpeak channels. We launched the mqtt.py file we were looking at with RGB equal to 1, which means track equal to 1. As you can see, this is the channel ID, this is the user API key, and this is the user API write key. Now, we are updating the channel with field 1 equal to 22, so temperature equal to 22, and field 2 equal to 45, and this is latitude and longitude, field 3 and field 4. As you can see, we are updating the channel. The same data we have there, we have also on Freeboard, and it's interesting in Freeboard to see at the map that it's moving actually from Piazza Carlo Felice to Corso Duca degli Abruzzi, as we were saying for the short trip.
I'm gonna show now the file where we compute statistics for the data we were posting on ThingSpeak. We start by doing a request to get the data from ThingSpeak. Then we are going to evaluate the average temperature and the average humidity. So here we have for temperature. We specify the field where we were posting the temperature on ThingSpeak. We load those values, sum and divide. So we have the average. We do the same for humidity. The next step then is to evaluate the warnings we were posting. If you remember, in the configuration, we defined an interval, a maximum and minimum threshold. Based on that, when we were reading the data with the sensor, we were deciding if in this field warning we were gonna post -1 if the value was below the threshold, 0 if it was between this interval, and 1 if it was above. So here we're gonna count how many of each value we have in the data set. And with this we can evaluate the percentage of time we were inside the threshold we wanted. We do the same for humidity here. So we have again the percentage of time we were inside the interval. We return all the computation we have made. We expose this function using here a get, and here we have our web server running.
Let's have a look on how is the bot working. The bot has a set of commands: get position, get temperature, get humidity, get all, that gets all the three of them together, and get stats, which gets some statistics on the previous temperature or humidity, or the times that the temperature and humidity have overcome the thresholds, and so on. Let's try, for example, the get all. So get all, and this is asking us for our pack code. We insert our pack code, and we are going to retrieve the information about the position, the temperature, and the humidity of the packet in that time. To understand how the bot is able to retrieve us the information, we go through the code and we look at the commands. For example, at the beginning, we have that the system tries to retrieve the information about the track in which the packet is contained, and then we go through the commands. So we have, as you can see, get position, get temperature, get humidity, get salt, and get stat that are the command that we have seen in the bot. And then, for example, we have a look at one of them, for example, get position, and then we check if the command is in the available service. Otherwise, we say that the operation is not available for this service, and we retrieve the list of all the commands that the user can perform. If the command is in the available service, we check if the packet is really in the system and contained in a track. Otherwise, we say that the packet is not in the system. And if the packet is in the system, we retrieve the position through the latitude and longitude. As you have seen, it's a map with the same location. In addition to the bot, the user can retrieve the information about the packet through a web page. It has only to insert this packet ID in this field and then search. And as you can see, here we have the map with the position of the track and so of the packet. And here we have the information about the temperature and humidity that are the same that we have on ThinkSpeak. For example, here we have 37%, and if we go on ThinkSpeak for the same channel, we have this 37%. So it's another way to retrieve the information to the user.
In order to have a complete simulation of our process, we implemented a multi-screen approach. In the top left corner, we have the home catalog and the Python file for the analysis. In the top right corner, we have a mobile phone with the application. In the bottom left corner, we have the Telegram bot and the Raspberry running on MQTT. And in the bottom right corner, we have the website and the database. After the initial phase where we start all the applications, including the home catalog and the Telegram bot and the Raspberry Pi, we decided to make a whole delivery from the customer going to our office to the delivery itself of the packet. When a customer goes to our office, an operator fills the form and adds the packet to the database, as we can see in the database section. After the packet is added, we retrieve a QR code that is printed on the pack so that the operator on the truck can scan it when it enters the truck and when it gets out. After the pack is scanned for the first time, we can see the request of association to the truck and its association to the truck itself. From that moment on, it is possible through the Telegram bot to retrieve all the statistics and the qualities of the pack during the journey. So with the getAll function, for example, we can get the position, the temperature and the humidity of the pack. Of course, if it takes too much to enter the pack code, we get a timeout and we have to enter the pack code again. Using the getAll function of the Telegram bot, we retrieve the position on the map, the temperature of the packet at the moment, and its humidity. In the meanwhile, the Raspberry has started to send infos to ThinkSpeak through MQTT. As we can see, the temperature data are changing as the position and the humidity data. All those informations can be seen both in ThinkSpeak and in Threeboard. In ThinkSpeak, we can also see the alarm for the temperature threshold. As we can see, if the temperature is above threshold, the warning temperature goes to 1. Vice versa, if it is below threshold, it goes to -1. If a customer wants to check his packet, he can use the Telegram bot and the website. In the website, he can see the position of the packet and the history of its temperature and humidity. The data plotted in the website are the same that can be seen in ThinkSpeak or in Freeboard. What's more, in the Telegram bot we can use the getStats function, retrieving all the information about the packet journey, like the average temperature, the average humidity, and if the packet has overcome the given threshold and how many times it has happened. As we can see in our simulation, the average temperature is 20.46 degrees and the threshold has been overcome twice. Instead, the average humidity has been 34 degrees and it has always been over the threshold. When the packet reaches the destination, our operator on the truck scans again the QR code, making so that the packet is delivered. Our database is updated automatically and the packet is marked as delivered.